Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Messier 2. So what do we see here? Well, here we see the second object in Charles Messier's catalog back in the 18th century, cataloging objects that are not comets. Now, these were a variety of different things, including M1, or Messier 1, which was the Crab Nebula, a supernova remnant, Messier 2 that we see here, but there's also galaxies and other types of nebulae that are visible in this. Now, Messier 2 is an example of a star cluster, and in fact, this case, it's a globular star cluster, and this is one of the largest of those. Globular star clusters exist in the halo of our galaxy. So our galaxy is a flattened disk with spiral arms, but around it is a spherical halo dating back to the very early stage of our galaxy when it first started to collapse and form. And these globular clusters are remnants of that early time. And they are very old then, 10 billion years old or more sometimes, and they form all their stars at once in a great burst at the beginning, forming all of their stars, and no stars form after that. So they are ways to test models of stellar evolution. We can see how stars have evolved. All the massive stars will be gone. And in fact, at this age, any star our sun's mass or more massive would already be gone. They do not live 10 billion years, so they would be gone in a cluster about 10 billion years old. And that allows us to catalog the various stars, figure out what's happening, and improve our models of stellar evolution. Now, this is a very high concentration of stars. We're looking at about the 40 light-year region, and we're seeing 100,000 stars. Now, that's a lot of stars in a very compact area, and that's very different than our own local neighborhood, where even 4 light years away, we haven't gotten to the nearest star. Here you could have dozens of stars very close to you if you lived on a planet around one of these stars. There would be lots and lots of stars. The sky would be much brighter than what we see around us, where there are very few stars. Within 40 light years, not a whole lot of stars. Yes, there's plenty, but not a lot. Not like you would see here, where you would have thousands and thousands of stars within that same kind of region. Now, the entire cluster itself is more like 175 light years across, and tens of thousands, more than 50,000 light years away from us. So these, again, are studied because they are some of the very ancient parts of our galaxy and give us a clue into the very early history of our galaxy. Now, globular clusters don't last forever. Often they end up being incorporated within our Milky Way. This is one example of that, where it has been taken apart a little bit, and it's just debris stream left behind from being disrupted gravitationally by our Milky Way. One was recently found associated with this specific globular cluster. Does that mean it's going to disappear in the near future? No, it could still take billions of years for this to occur. But eventually they end up, as they pass through in their orbits, could end up being incorporated into the general Milky Way galaxy itself. So that was our picture of the day, titled Messier 2. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.